this video, we're going to take a look at a Leetcode problem called longest palindromic subsequence. So we're given a string, we want to find the longest palindrome subsequence. In our subsequence, the characters doesn't have to be right next to each other, right? So I can have BBB, I can have AB, right? I can also have BA, that's a substring, where I can have B here and A here, right? So in this case, the longest palindromic subsequence is going to be BBBB, right? Because I can have 3 B's here, ignore the A, this will give us a palindrome, right? If I reverse that string, it will give us the same. But I cannot have A here, because if I have A, then in this case, I cannot find a palindrome subsequence. And you can see here we also have CBBD, and the longest palindromic subsequence is going to be BB, right? So I cannot have CB or BD, or I cannot have CBBD, because these are all non-palindrome. So the palindrome subsequence is going to be BB, right? So in this case, the answer is going to be 2. And notice that we're returning the longest palindromic subsequence, right? The size of the subsequence, right? So how can we solve this problem? So to solve this problem, we're going to use a 2D cache array. And basically the goal is that we can use a 2D cache array to store the longest palindromic subsequence from I to j, right? In this case, I is less than j. So in this case, if we have a string and we want to find the longest palindromic subsequence, we can be able to store that in our 2D cache array. And this will basically solves our subproblems, and we can use those subproblems to solve the bigger problems, right? So in this case, how can we do that? We can be able to do that using a bottom-up approach, just like how we do it in other dynamic programming problems, where we do a top-down and bottom-up approach. Basically, go from the bottom, where we solve the small problem first, where we solve the bottom problems, like the subproblem of the subproblems. And then once we solve those subproblems, we can be able to solve the bigger problems, right? So in this case, the bottom problem, or the smaller problem in this case, is that if we have a base case like this, where we have empty string, right? In this case, if cache I, right? In this case, the first one is the starting. In this case, you can see here, the starting is I, and the ending is I minus 1. Basically means that if our substring is empty, then in this case, we have 0. The longest palindromic substring is 0, right? And if we're starting at 1, if we're starting at I, ending at 1, ending at I, right? If I is equal to 1 or I is equal to 0, if we're starting at I, ending at I, that's just one character. And if we only have one character, let's say A, the longest palindromic subsequence is going to be 1, right? So that's how many longest palindromics, that's the longest palindromic subsequence that we can find out of this entire string, right? So if we have now if we want to go up, like let's say we have the size of 2. So what's going to be the longest palindromic subsequence? We're the LPS, right? So in this case, the longest palindromic subsequence for this string right here, if you're starting at 0, ending at 1, is going to be 2. Because if we're starting at here and ending at here, what we're going to do is we're going to have 2 pointers. One pointer is pointing B, the other pointer pointing to another B, right? In this case, we check to see if those two are equal to each other. If they do not equal each other, right? So if they do equal each other, then what we're going to do is we're actually going to +2. In this case, at this position, the longest palindromic subsequence, if we're starting at 0, ending at 1, is 2, right? Because those two characters are, those 2 pointers, the elements that those 2 pointers are pointing to are equal to each other, right? And if we have A and B, in this case, A, B does not equal each other, then what we're going to do is that we're going to for the current position, the longest palindromic subsequence is either the first half, right, or the second half. In this case, the first half, we already computed that before, right? In this case, it's starting at 0, ending at 0, or starting at 1, ending at 1. So the longest palindromic subsequence at the current position is either here, right, from 0 to 0, or 1 to 1, right? And then we have size of 3. If we have a size of 3, the longest palindromic subsequence is either AB, in this case, we have ABA, in this case, from 0 to 2. In this case, those 2 pointers, those elements are equal to each other. In this case, A is equal to A. And then what we're going to do is we're going to +2. For this position, from 0 to 2 is 2 plus the longest palindromic subsequence if we're starting at 1, ending at 1, right? Because once we, just like how we did it, how we check to see if a palindrome is a palindrome, we're going to have a left pointer and a right pointer. And then what we're going to do is we're going to move our pointers closer to each other. So we're going to use this, we're going to use cache to cache this result, right? So in this case, we already computed what's the longest palindromic subsequence if we're starting at 1, ending at 1. So we can use that rather than just getting those pointers closer to each other and one by one. This will give us a linear time complexity. So what we can do is we can just store that in our cache array, and then we can just say, okay, if the I pointer move 1 to the right and the J pointer move 1 to the left, then did we compute that before? In this case, we did. It's cached at 1 at 1. So in this case, that's the longest palindromic subsequence for that position, right? And we're going to look at an example and in a table form, and I'll show you what I mean by that. But you can see here, if I have a situation where string at I does not equal to string at J, then we're going to do this. We're going to, just like how we did it here, we're going to take either the longest palindromic subsequence from here to here or B to A. This is basically the core here, is that if the left pointer and the right pointer does not equal each other, right? In this case, the element at left does not equal the element at right, then it's going to be the maximum value, the maximum longest palindromic subsequence from 0 to 1 or 1 to 2. And this will give us the longest palindromic subsequence from 0 all the way to 2, right? So you notice that we're going from the bottom to up, and it might be confusing at this part, but if you know how we solve it here, it might be a lot easier, because when at the bottom, right, if I want to know the palindromic subsequence, the longest palindromic subsequence for this, is either this part right here or this part right here, because those two does not equal each other. And if we have a situation where those two does equal each other, then in this case, we can just plus 2, right? The longest palindromic subsequence that we have seen so far is just 2, because those two are equal to each other. And now what we need to figure out is the inner part. In this case, there's nothing that we have because this is an even palindromic, right? In this case, those two, there's nothing inside those two characters. So the longest palindromic subsequence that we've seen is 2, right? Just like how we do it, check to see if this is a palindrome, right? We have a left pointer, we have a right pointer. We starting from the outer, right? The outer characters. We moving in, right? And check to see for each and every single character, does those characters equal to each other? In this case, if it doesn't, this is not a palindrome. If it does, we're just going to we're just going to keep going, right? In this case, until we met the center character. And it's the same thing. We're basically just caching that, and then so that we can be able to solve it in a faster time, in a big O of n squared time complexity, right? So now let's take a look at an example. So you can see we have a G, B, B, D, B, A. So we have a string, and the answer is that we can just take A, B, D, B, A, right? Ignore the G. We get the longest palindromic subsequence, and the size is 5. So let's say we have these characters in our strings, and these are the index. So what we're going to do is that we're going to start at the bottom. So if we know that we're starting at 5, right? Because remember, the rows are the starting index, right? In this case, if we're starting at 5 and we're ending at 5, what's the longest palindromic subsequence? In this case, if I only have this one character right here, because we're starting at 5 and end at 5 is just going to be 1. And if we're starting at 4 and we're ending at 4, right? If we only have just this element right here, we also going to have 1. And if we're starting at 4 and we're ending at 5, right? If we have this one right here, the longest palindromic subsequence is going to be what? It's going to be the substring is going to be BA, right? And in this case, it's just going to be B or 1 or B or A, right? In this case, in our subsequence. And we know that in our left pointer and our right pointer does not equal each other. So what we're going to do is we're going to take either the in this case, cache at, right, cache at 4 to 4. So the maximum cache to 4 to 4, or cache at 5 to 5, right? So this will give us the maximum value. In this case, the maximum value is just going to be 1, right? Because in this case, the longest palindromic is either B or A. And then if we're here, right, if we're starting at 3 and the ending is at 3, right? If we only have one character in our substring, it's just going to be D, so it's just 1, right? And if we're starting it here and ending it here, if we're starting at 3 and ending at 4, we have D and B. So the longest palindromic subsequence is just 1, right? And you can see that is either D or B, but we already compute that, so we check to see if starting at the substring starting at 3, ending at 3, or the stop substring or the subsequence, longest palindromic subsequence starting at 4, end at 4, right? So you can see that was based on the two elements at the left and the bottom. So it's just going to be 1, right? And then we also starting at 3, ending at 5, right? In this case, there's no palindrome there because D does not equal A, so it's either DB or BA, right? In this case, the longest palindromic subsequence that we have seen is just 1. Okay, so now we move on to the next column. In this case, sorry, the next row. In this case is 2, right? So if we're starting at 2, ending at 2, then we'd only have B, so it's just 1. If you're starting at 2, ending at 3, the longest palindromic subsequence is just 1 as well, right? And if we're starting at 2, ending at 4, okay, well, we have BDB, right? So in this case, we have the outer pointers. In this case, these pointers are equal to each other. So we know that those two are equal to each other. So we're going to have 2 plus the inner element. In this case, the inner element is that the inner substring is from 3 to 3. So we already computed that before because 3 to 3, right, is 1. So 2 plus 1 will give us 3, okay? And then here we also have 1. In this case, if we're, here you can see we are starting at 2 and ending at 5. So in this case, we have B, A does not equal each other. So is either this half right here or this half right here. So we already compute that, right? So in this case, 2 to 4 is BDB, and 3 to 5 is DBA. So 2 to 4, okay, 2 to 4 is 3, and 3 to 5, well, 3 to 5, which is 1. So the maximum value out of those two is just going to be 3, right? Which makes sense because if this is our substring, the longest palindromic subsequence is BDB, right? It's going to be a size of 3. So we're going to save that in our cache table. And now we move on to the next row. In this case is 1, right? If we only have 1 and ending is 1, so this is going to be 1. We only have 1 palindromic subsequence. And if we have starting from 1, ending at 2, the longest palindromic subsequence in this case is just going to be GB, right? So GB does not equal to each other, right? G does not equal to B. So in this case, the maximum either this one right here or this one right here, right? So in this case, it's just 1. So now we have GBD. In this case, GBD, the longest palindromic subsequence, right? In this case, it's just 1 because these two does not equal each other. So it is either GB or BD. In this case, GB, right, 1 to 2. In this case, we already cached that. It's just 1. And 2 to 3. So 2 to 3 is here. So we also cached that as well. So the longest palindromic subsequence is just 1. And here is the same thing. So 1 to 4. Okay. So in this case, GB does not equal each other. So we're going to either take this half or this half. In this case, the longest palindromic subsequence you can see from 2 to 4 is 3. And from 1 to 3 is just going to be 1. We already compute that. So just going to be 3 because 3 is bigger. So now we have 1 to 5, right? It's getting close. So if I have 1 to 5, then in this case, G does not equal to A. So is either GBDB or BDBA, right? So in this case, we can have 2 to 3, 2 to 5, or 1 to 4. So 1 to 4 we already compute as 3, and 2 to 5 we also compute that, which is also 3. So the maximum is just going to be 3. Okay, so now we're here. If we're only have one character, which the first character is just going to be 1. If from 0 to 1, it's also going to be 1. From 0 to 2, right, 0 to 2 is also going to be 1 because those two does not equal each other. And 0 to 1 is 1, and 1 to 2 is 1 as well. And if I go from 0 to 3, it's same thing. In this case, is either 0 to 2 or 1 to 3. So in this case, it's just 1. And now we have 0 to 4, right? In this case, 0 to 4, those two does not equal each other. So A, B does not equal each other. So it's either going to be 0 to 3 or 1 to 4. So 0 to 3, we already compute that as 1. And 1 to 4, in this case, 1 to 4 is 3. So the largest value is going to be 3, right? And if we starting at 0 and ending at 5, well, in this case, those two are equal to each other. A is equal to A. And in this case, we can plus 2 because we have those two elements equal to each other. So now we basically move the pointers inner. We want to know the longest palindromic subsequence from here to here. So the longest palindromic subsequence, we go from 1 to 4. In this case, from 1 to 4, we already cached that because from 1 to 4 is 3. So in this case, 2 plus 3 will give us 5, right? So the longest palindromic subsequence go from 0 to 5 is just 5, okay? So basically, this is how we solve this problem using 2D array. And you can see that for each and every single row, we need to, the current element is based on the current row and the previous row, right? Or the bottom row, right? In this case, the bottom row, if I want to know this position, I need to know the bottom row, right? So this will give us the computation or the result for the current element's position in the current row. So now let's take a look at how we can do this in code. So you can see that like basically we going from bottom to up. So there are two ways to iterate this. We can go from, in this case, I is equal to n minus 1 or the last row. And in this case, we also have a j pointer. J is equal to I plus 1. While j is less than n, we're going to compute each and every single remaining elements, right? Or we can do, you can see here, if we're, because we're going from bottom to up, if we're here, right? If we're here, then in this case, I can have a j pointer that's I plus 1 and iterate the remaining elements, right? So this will give us each and every single position of that row, and obviously other than those empty spaces, but we compute those values and save it on our cache. Or what we can do is we can have j is equal to n minus 1, and while j is bigger than I, right, then we can just iterate those elements. We can iterate backwards, right, and no problem as well. So let's try to do this in code. To do this in code, first let's have a 2D cache array with a size of n. N is going to be the size of the string. So let's convert the string into a character array first. So s.to character array. And what we're going to do is we're going to say n is equal to array.length. Okay. We're going to have a table with n times n. Okay. And basically for each and every single, the row represents the starting of the substring and the column represents the ending of the substring. So let's iterate the table using this one. So we're going to start at the bottom and we're going to have a j pointer is equal to I plus 1. So we iterate from j all the way to n, and basically we check to see if this value is we basically compute that value, right? So we basically compute from the starting, which is I, and j is going to be the end of the substring. So integer I is equal to n minus 1. I is bigger than or equal to 0. I minus minus. Okay, so we have the i's kind of like our starting pointer, and we also have our j is equal to I plus 1, which is the ending pointer. So j is less than n, then j plus plus. And basically we iterate for each and every single iteration. We're first going to set the I pointer. So cache at I is equal to 1. You can see here, if we only have one character, is 1, right? If we're starting at 1 and end as 1 is 1, right? So what we're going to do is here, we're going to say cache at I is equal to 1, okay? And then what we're going to do is we're going to iterate, in this case, j, right? So if we're, so cache at I to j, at I at j, right? So we're going to check to see if array at I is equal to array at j, because we want to check to see if the outer elements are equal to each other, right? We're going to have our pointers, one points to here and the other points to the end of the substring, right? We want to see if they equal each other. If they do equal each other, then what we're going to do is we're going to get the cache at I at j, right, is equal to 2 for now. And then what we're going to do is we're going to, because there could be a situation like this one right here where we have an even number, then we just have, you know, in this case we just have 2, then at this position the longest palindromic subsequence is just 2, right? But if we have a situation where we have an odd number, where we have a substring that's bigger than 2, we have a 3. So we want to see if I plus 1 is less than j. If that's the case, where we have an inner element, then we're going to get cache at I at j plus equal to cache at I plus 1 and j minus 1. Right, we're moving our pointers close, right? We're moving our pointers shorter, so we want to figure out, you can see here, we want to figure out from cache to 1 to 1. This shouldn't be 0, this should be 1 to 1. You can see we want to know the longest palindromic subsequence for the inner element, right? So this will give us the result. Otherwise, if we have a situation where the outer element does not equal each other, then what we can do is we can say cache at I at j is equal to the maximum value. Either the, in this case, is either the cache at I plus 1, right? So it's going to be the next element, right? So the next element to j, or it's going to be starting at I all the way to j minus 1, okay? So this will give us the maximum value out of those two substring, right? And then at the end, we're just going to get our results. And what we're going to do is, because we know our results is at the top position, at the top right position, so we're going to return that value. So it's going to be cache at 0, right, the first row, and n minus 1, right, the last column. So now let's try to run our code. And let's try to submit. You can see we have our success. So this is how we solve this problem, and the time complexity for this problem is going to be in square because we're iterating each and every single position in our 2D array. And the space complexity is also going to be in square.